easy electronics. Today's video we are going to see about the Klystron, that is the two cavity Klystron. It is a microwave amplifier, can be also used as an oscillator. We'll be seeing about the concepts and the most important questions which can come from this area of a Klystron. Okay, so this is a two cavity Klystron and it is used as a microwave amplifier. That is, if you want to apply or if you want to amplify a microwave signal, we apply it to one cavity when we take the output from the other cavity. So it consists of two cavities, that is two resonator cavities it consists of. The first cavity is called the buncher cavity, the second cavity is called the catcher cavity. Let us see what is the basic working of a two cavity Klystron amplifier on an exam point of view. Okay, so if you see this side, you can thought of this side as an input side. It consists of a cathode. And if we use a hot cathode, this cathode will be producing or emitting of electrons. And these electrons are attracted towards the anode side. You can see an anode side here. So the electrons emitted from this hot cathode is attracted towards the anode and it will be forming a beam of electrons and it will flow through this path. Okay, so this is a path of the electrons, and in order to prevent the scattering of this beam of electrons, we use two magnets and it will help in the spreading of, that is, it will help in preventing the spreading of the electron beam and it will allow the path of a narrow beam of electrons. Okay, then it will reach the first cavity which is called the buncher cavity. So this part you can think of as a electron gun. Okay. So in some textbooks it will be written as electron gun, that is the part where the electrons are produced or emitted. You can call it as an electron gun. Generally it consists of a cathode and an anode. Okay. Now this electron beam reaches the buncher cavity. The input microwave which we want to amplify is fed to the buncher cavity, which is the first or the input cavity. Input cavity is a buncher cavity and you feed the input signal to the buncher cavity, and this microwave signal is fed in the same frequency as that of this resonant cavity. These two cavities are resonator cavities and it is having some resonant frequency. Your input fed is nearly equal to or same as that of your buncher cavity's resonant frequency. And hence, that is when we apply the signal in the resonant frequency of this cavity, some standing waves will be created and some oscillating voltage will be generated in this buncher cavity. Waves is generated and this standing waves inside the buncher cavity will produce some oscillating voltage. Okay, so an oscillating voltage will get generated in the buncher cavity due to this applied microwave input. And this oscillating voltage inside the microwave buncher cavity will cause the bunching of these electrons. Okay, so that is the principle of operation of this buncher cavity. So due to this bunching of electron beams, we call it as a buncher cavity. Okay, I hope it is clear. Now this electron will form as bunches and it will pass through the next region which is called the drift space. This is called the drift tube or the drift space. That is space between buncher cavity and catcher cavity. This is another important term. Is called the drift space. Through this space, the electrons will drift, and these electrons will in turn form as firm bunches through this drift space, or they move in the form of bunches through this drift space, and then they reach the next cavity which is called the catcher cavity. Okay, so this is the next cavity. In the catcher cavity, the field or the electric field is applied in such a way that it will decelerate or it will block the flow of electrons. Okay, so here the electrons are getting amplified and forming as bunches and they are reaching the catcher cavity, whereas in catcher cavity they are actually decelerated. The highly moving or high speed electrons are actually decelerated. That is, their movement is prevented in the catcher cavity due to the applied electric field. Okay, so they are decelerated and they will get slowed down. So the speed of these electrons will get reduced and their kinetic energy is converted into potential energy. So if you see from this side, earlier the electrons was having potential energy. They were accelerated due to the field in this buncher cavity and their potential energy was actually converted to kinetic energy, right? The potential energy equation is E into V, where E is the charge of the electron, V is the potential, and their kinetic energy was half mv square, where m is a mass, v is the velocity of the electron. So these electrons were actually accelerated or were getting speed up or energized in this area, that is in the buncher cavity and the drift space. Whereas in the capture cavity, this kinetic energy is converted back to the potential energy. That's what I'm saying. That is, they are getting decelerated. Their energy is reduced. Okay, so the electrons will get slowed down and the field in that area will get energized due to this converted energy. That is, they absorb energy. We can think of like that. That is, the field in that area will absorb energy from these highly energized electrons, and the field itself will get energized. And due to this energized field, the microwave signal will get amplified. I hope this is clear. This is a very simple principle of working of this two-cavity Klystron amplifier. That is, you can think of, that is, first the electrons are energized, then the electrons are de-energized, and this energy which is taken from these electrons are given to your microwave signal to get amplified. This is a very basic principle or very simple way of explanation of this two-cavity Klystron. Electrons are, or electron beam is generated, electron beam's energy is boosted. In the buncher cavity, they are formed as bunches. In the capture cavity, this electron's energy is reduced. This energy is absorbed by the field, and this field gives this energy to the microwave signal to amplify it. Okay, so this is how the microwave signal is getting amplified, and this is the principle of working of a two-cavity Klystron. Now here you can see a collector. This collector is actually used for collecting all the de-energized electrons. The electrons are now slowed down, right? The electrons' energy is being absorbed by the field, and the electrons are now slowed down. So these slowed down, de-energized electrons are absorbed at the collector side. This is also an electrode. This collector electrode will absorb or collect all the electrons. So this is happening here. In the from the electron gun, electrons are generated and collected towards the collector. Okay, so this is the basic working of a two-cavity Klystron. Now, what are the important questions that can come from this area? Okay, now I'm going to discuss all the important questions that can come from this area. The first question is the two-cavity Klystron a source? That is this two-cavity Klystron able to generate some energy? No. This two-cavity Klystron is actually an amplifier. It is not a source, or it does not generate energy by themselves. Okay, it just amplify your microwave signal which we want to amplify. It is an amplifier, not a source. Okay, it is just an amplifier. Now, what is the velocity of movement of the electron beam or the electrons? So I have told that it is just conversion, or simply you can write it as conversion of energy. That is, potential energy is converted to kinetic energy while the electrons are getting accelerated or moved. So potential energy equation is E into voltage applied. Kinetic energy is equal to half m velocity square. So you can equate these two energies, that is half mv square is equal to ev, that is 2 ev by m square root is the velocity of moment of this electron beam or electron. Velocity v is equal to square root of 2 into E, which is the charge of an electron, into voltage applied by m. That is this equation. I'll write it once again here. Velocity of movement V is equal to square root of 2 into E into potential V by mass of the electron. So this term indicates that this velocity of electron is affected by the applied potential. That you can also see here, right? Here, due to the applied potential or due to the potential generated, the electrons are getting accelerated. Here, due to the effect of potential, the electrons are getting decelerated. That is, velocity is reduced. So, velocity is highly dependent on the potential applied or the voltage V. Okay, so this is the equation for finding the velocity of the electron in the klystron cavity. Next question, what is the principle of operation? I'll remove this side. I hope you have noted the figure. So what is the principle of operation of a two-cavity klystron? That is the next question. The principle of operation of a two-cavity klystron is nothing but velocity modulation. Velocity modulation is the principle of operation of a two-cavity klystron. You can see that the velocity of what is modulated here, the electron beam is actually modulated. Earlier the velocity in the first cavity is increased, then it is reduced. Hence the velocity is getting modulated, and that velocity modulation is used for energizing the microwave input. That is a principle of operation of a two-cavity klystron. It is a velocity modulation. Okay. Classification of klystron are done based on dash. The classification of klystron, I have told at the beginning itself that klystron can be used as amplifiers and oscillators. But the major classification of these klystrons are done based on the electron beam field interaction. That is, this electron beam is actually getting modulated with the applied field or voltage, right? So, based on this electron beam and field interaction, we can classify the klystron, and the classification is like this: linear beam or O beam klystron and cross field klystrons. That is, linear field or cross field. Okay. So, the klystron which we have discussed today is actually a linear beam klystron. Okay. So, this is the classification. Main classification of klystron can be done based on the interaction of electron beam with the field. Can be classified as linear field or cross field, O beam or M beam. Okay, it is like this: O beam or M beam. Next question is, two cavity klystron amplifier is a dash type beam amplifier. The klystron which we have discussed today is a two cavity klystron amplifier, right? It is a linear beam type amplifier. Okay, so the klystron which we have discussed today is a two cavity klystron amplifier. It is a linear beam type of amplifier. Dash is a single cavity klystron tube used as oscillator. Reflex klystron is a single cavity tube which can be used as oscillator. I have told in the beginning that this klystron can be used as oscillator and amplifier. That is, for oscillating or generating of waves, and also it is used as amplification, for amplification purpose. Okay, so if we use a single cavity, in today's video we have discussed klystron with two cavities, Buncher and catcher. But if we are only using a single cavity klystron, it can be used as a this single cavity klystron which can be used as an oscillator, it is called a reflex klystron. Okay, so you should be knowing that the reflex klystron is an oscillator. Okay, next one. Also, another example of this oscillator type of klystron is magnetron. Magnetron is also an oscillator. Okay, next, another important question is that what is the major disadvantage of a klystron? The major disadvantage of a klystron amplifier is that it is having low bandwidth. The klystron amplifier is having only low bandwidth. That is the major disadvantage of a klystron amplifier. Now, how can we overcome this disadvantage? This disadvantage can be overcome by increasing the number of Buncher cavities. Okay. So, we have discussed a klystron with a Buncher cavity and a catcher cavity. But if we place more than one Buncher cavities in between this Buncher and catcher cavity, So all these are bunches, okay? B2, B3, B4. Likewise, if we increase the number of buncher cavities, then we can increase the gain and also bandwidth, okay? So in order to overcome the disadvantage of low bandwidth, we can increase the number of buncher cavities, and hence we will be forming multi-cavity klystron. So we have discussed today about two-cavity klystron. There are multi-cavity klystrons with more than one buncher cavities, and this increasing of buncher cavities is actually to improve your gain and also bandwidth. Okay, so these are the important concepts you should know about a klystron. There are also other type of klystron. There is traveling wave tube, which is a high bandwidth amplifier, microwave amplifier, which is a traveling wave tube, TWT. There is magnetron, there is diatron, there are varieties of actually klystrons. Okay, so anyway, these are the basic things and basic classifications of klystron and the basic working of a klystron. Two cavity klystron we have discussed. So there are a lot of questions that can come from this area. That is, what is the first cavity, or what is the input cavity, what is output cavity, how the electrons are generated, what is the principle of operation, what is the energy conversion taking place here, how the acceleration of the electrons is happening, how the wave is getting energized. All these things can be asked as theory questions. I really hope that this video is useful for figuring out the basic working of a two-cavity klystron amplifier specifically on an exam point of view. So if yes, please do give it a thumbs up and also share this video with maximum of friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.